Okay, in this part of the question, we are asked to describe the path of the electron that passes through the minimum potential point. I find this question impossible to answer because it's too complicated. So let me change the question to one that I can answer first. So I'll change the question such that the two spheres carry the same charge and the same dimension and everything. So if that's the case, then the resultant field of these two spheres will also be symmetrical. The minimum potential point will be right at the middle of the two spheres. And so to pass through that point, all I'm going to do is I'm going to let go of the electron somewhere also along the bisector of the two spheres. And everywhere along this line, the resultant pull of these two spheres will be a vertical force. So you only have a y component, there will be no x component. If that's the case, then you know that the electron will simply speed up until it passes the minimum potential point. It will slow down, come to rest, and then come back, speed away. So it's going to be an oscillation. That's the question which I can answer, provided the two spheres are identical dimension and they have the same charge. Alright, let's come back to this question. This question has the two spheres which carry different charges. So the resultant electric field is not symmetrical. So this is like the artist's impression of what the electric field may look like. So you realize it's not symmetrical and the minimum potential point is not at the midpoint. It's closer to sphere B. So where do you think we should let go of the electron such that it will pass through this point? It's not a trivial question. It's very tough. My best guess is maybe you plonk it somewhere here, sort of like aligned with the minimum potential point. When we are far away, it's possible that the resultant of these two spheres electrical attraction force could be a vertical force. But when you're nearer here, surely the resultant of the two attractive forces will not be directed this way. Either this guy pulls it stronger or this guy pulls it stronger. So the path will not stay on this straight line. It will either veer one way or the other. The path could be very unpredictable. It could be this way, it could be this way, I don't know. I have no idea what the path will look like. That's why my own answer, I gave something that's pretty vague. All I say is the electron is going to speed up as it approaches the line. It will reach the maximum speed when it crosses the line, and it will slow down as it moves away. And all I can tell is it's probably not a straight line. It's probably going to be a curved path. So this is the best answer I can give. As for what the setter actually had in mind, well, you got to ask the setter. Okay, that's all I have to say. Ta-ta!